Which space mission would I save from cancellation if I could? Is fighting space junk with lasers a good idea? What if we find asteroids that have already been mined? And in our Q&A Plus on Patreon, how do we measure the masses of black holes? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. AshStar, if you could save one mission from cancellation or expand its budget, which would it be? That is a brutal question, and you're a very mean person to ask me this question because now I have to pick my favorites. Currently, right now, we know that the White House is requesting a skinny budget for NASA, and we're waiting to find out from Congress whether they're going to pass this, and then we will see the budget get 25% smaller. And if it does, then there will be missions on the chopping block. And right now, we don't know which ones they're going to be, but something has to get cut, especially from the Science Directorate, which is the part that they're looking to make the deepest cuts to. And a lot of my most favorite missions come from that. So I will give you them in order of increasing excitement. So number 3 is the Nancy Grace Roman telescope. And of course, this is the successor, I guess, to the Hubble Space Telescope and James Webb. It's the next telescope that is going to be Hubble size, but it has this enormous field of view, and it's going to be participating in these giant scans of the universe, trying to measure the impact of dark matter and dark energy over time. And the telescope is largely constructed. It still has to go through a shake test and has to get its solar arrays installed, but they're all ready to go. And then if all goes well, it'll launch in less than 2 years. And that just, like, why would you not? It's on budget, on time. Just let it go to space, please. So that one would really suck if it didn't go to space, because it's ready to go and it has some big, like, it'll be capable of finding exo-Jupiters, directly observing Jupiter-sized planets orbiting around sun-like stars, which is, we know of super Jupiters, but we don't know of a lot of these just like smaller or regular Jupiter distance from sun-like stars. And this is testing this new technology that will be a precursor to the number 2 mission on my list. And that is the Habitable Worlds Observatory. And again, Habitable Worlds, if these cuts go through, will probably go on the chopping block. And this will be the telescope designed to directly observe Earth-sized worlds orbiting around sun-like stars. This is going to be the telescope that will help us find another planet that is very similar to Earth in the habitable zone. And it will be able to measure the atmosphere of the planet. It's going to be building on the technology that they're testing with the Nancy Grace Roman telescope, this coronagraph designed to spot these Jupiters. So Habitable Worlds will take that technology to the next level and actually be able to observe exoplanets. And it's estimated that they will be able to look at dozens of other Earths. So Earth-sized world, sun-like star, habitable zone, examine the atmosphere. And that will give us one of the best senses of just how alone we are in the universe. So that's my number 2 mission that I would be the most sad if they canceled. And number 1, with a bullet, would be Dragonfly. And this is the mission that's going to be going to Titan. It is a octocopter powered by a radioisotope thermoelectric generator. This is like a decaying piece of plutonium. It's the same thing that you see in Curiosity and Perseverance. And this octocopter will be able to fly around in the thick atmosphere of Titan and observe features on the surface of this world. And Titan is so great, right? It's one of the other places, the few places in the entire solar system that you could go to and walk around and not immediately die without a spacesuit, without a pressure suit. The pressure is more, the air pressure is more than what we have on Earth. You would need a really thick coat to keep yourself warm, and you need a way to breathe, a breathable atmosphere, but you wouldn't have to worry about, the damage you would experience from being in low pressure. It probably, like Europa, like Enceladus, has this ocean of liquid water surrounded by this thick layer of ice. But then on top of that are hydrocarbons, the kinds of organic compounds that we're made of. And it is just on this layer on the top. It rains methane on Titan. And it blows my mind. I have to pinch myself to think that there could be a octocopter flying around in the skies of Titan, giving us incredible views from the surface. Like, we have one picture from the surface of Titan that was taken by the Huygens probe, which was dropped by Cassini when it first arrived at the Saturn system. And the image is amazing. And you look out on this landscape and you see it's weird and it's alien and it's tinged with orange, and there's so much possibility out there on that horizon. And so I would love to see something that can fly around and go like, what's over here? What's over there? Let's look at this. Let's examine this rock made of ice. So yeah, those would be my top 3 that I would be the saddest, and if they were to get cut. Like, you're going to see me openly weep if any of those missions get cut in the coming months. This is going to be terrible. Fearthelettuce. Why is it that missions are designed to last for a short period of time but end up lasting much, much longer? For example, Curiosity was designed for 1 Martian year. Yeah, I mean, when people are designing and building these missions, they are planning to build them for as long as they can possibly last. And there is a nominal mission where the scientists are hoping to get all of their science results out of it. But, once you cross that nominal mission and the spacecraft is still in good health, then it just keeps going. And we've seen this many times before. When you think about, say, Spirit and Opportunity, those 2 rovers had a mission of 90 days, and I think Opportunity lasted over a decade. That they just kept doing science for years and years on end. And there are spacecraft out there, think about the Voyagers, launched in 1977, and they're still going. They hit 50 years yet, right? And so, what do you need for a long-lasting mission? The missions that have a very specific timeline are the ones that are going to run out of propellant. The ones that are in an orbit where they have to maintain that orbit, and once they run out of propellant, then they're going to drift out of it. And Gaia is a good example of that, right? The Gaia mission is at the L2 Lagrange point. It lasted as long as it could. They got as much science out of it, but in the end, it ran out of propellant, and then they had to turn it off. James Webb is going to last probably for 10 to 15 years, but it's going to run out of propellant, and then they're going to have to just let it drift off into space. But for the other spacecraft, if you're using reaction wheels to turn the spacecraft to look in different directions, the reaction wheels can go eventually over time, but they can also last for a really long time. If you're using solar power to replenish your electricity, that goes on forever. It's unlimited. And so really, it's just a matter of how long your spacecraft will last until too many cosmic rays knock out pieces of the memory and degrade the processor. If you're one of the missions that uses a radioisotope thermoelectric generator, like Curiosity, like Perseverance, like the Voyagers, then you do have a time frame for how long you're going to be able to run your spacecraft. That the plutonium eventually starts to run out of heat. Takes about 50 years. And so theoretically, Curiosity and Perseverance could last for decades. I mean, Curiosity is up to 2012, 13 years, and still going strong. And so I wouldn't be surprised if they got another decade out of Curiosity. And the same thing for Perseverance, 20 years, 30 years, no problem. But then the power source will start to run down. They will start to have to shut off some of the electronic equipment. It'll have a harder time keeping itself warm during the night. And eventually it'll run out of power and they'll have to shut it down. So, this is an example where people, they underpromise and they overdeliver, which happens so rarely. But I think spacecraft engineers have this pride of knowing, I'm sure they have some inside joke, right? How long is this thing going to last? Well, the mission is a year. Yeah, but how long will it really last? And they're like, 100 years? It's time to shout out our new patrons at the $5 level and above. Daniel, Pathfinder C24, Mark Fusa, Hudson Ward, William Bednar, Philip Rogers, Andrew Collado, Kenneth Bauer, Droopy GT, and Marcus Heights. Join the community at patreon.com/universe today. Briar Patch, lasers in space to help push the space junk back into the atmosphere, good or bad? That's good. I think, space junk is a growing problem, and there are not very many solutions that you can do to deal with all of the space junk that's already there. All the little bits and pieces of debris, the astronaut gloves, the chunks of shredded spacecraft that are orbiting around the Earth, and they potentially are going to be hazards to each other. So how do you get rid of them? Well, the problem is that if you try to clear a piece of space junk out, to like catch a piece of space junk, you have to match its trajectory. And the only way to match its trajectory is to launch a rocket. And so it seems ridiculous that if you want to grab a 10-kilogram piece of space junk, that you have to launch a $200 million rocket to chase down that piece of space junk, to grab it, and then you deorbit with that piece of junk. That's crazy. But the only feasible solution to get rid of large amounts of space junk will be lasers. That you have a constellation of laser satellites that are flying around the Earth, and then they're constantly targeting all the different pieces of space junk that fall within their field of view. They fire the laser for just a short period of time. That vaporizes a little bit of material on the surface of the space junk. That causes a thrust in the opposite direction. It's a propellant. You can then use that to very slowly lower the orbit, accelerate the reentry of all of this junk back into the atmosphere of the Earth. And then you don't have to actually go and chase these things down. You're just zap, 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 and each laser could work for years and years and years, bringing all this junk and debris down. And when you think about how we want to go to another star system, right? We want to use laser sails. We would be great to have lasers in space that we can use to accelerate these spacecraft. And so if we get really good at this, you can imagine these lasers doing dual duty. They are clearing up the space junk, and then when somebody wants to deploy a bunch of laser sails to go around the solar system, or maybe even to other stars, they can do that dual duty. And in both cases, the stronger the laser, the better the effect that you're going to get. The faster you're going to be able to accelerate your spacecraft to other stars, the faster you're going to be able to cause all of that space junk to be deorbited. And the lasers would let you deorbit the stuff that is too high, too far away. Like the stuff that's down 300, 500 kilometers altitude above the surface of the Earth, it's all doomed and going to re-enter the Earth's atmosphere within a decade anyway. But the stuff that's above the altitude of the International Space Station, stuff that's up to 1,000 kilometers altitude, it could last 100 years, 1,000 years if you go higher. Well, the lasers could bring them down too. So I think that in the end, high-powered lasers in orbit are going to be the only solution. But obviously, you can think of the security consequences of this. Who's in charge of giant, powerful lasers that are flying overhead, capable of blasting holes in spacecraft? Maybe they could be pointed down at Earth as well. So it's probably the technological solution that will get us out of the space junk mess that we found ourselves in, but it's going to require people to get along and come up with a solution to work together. Marie Le Misérable. I never see ads on YouTube because I use Pi Adblock, and it's free. It's not free to me. I don't care. Use Adblock all you like. If I could turn off the ads on this channel, I would, because we've removed all of the ads from every other part of our content. We have no ads. We don't do any mid-roll ads. We don't put any no ads on the newsletter, no ads on the website, no ads on our on the Patreon versions of everything we do, no ads in the podcast. YouTube won't let us not put ads at the beginning. If I could turn them off, I would. Mike D, what happens if we start mining asteroids and then discover that they've already been mined? I think you just put together the synopsis of a really cool science fiction story. And the thing that you're proposing, or I'm hoping that you're proposing, is that maybe there were von Neumann probes that were here in the solar system. The future of space exploration, the one that seems most likely to me, is that we will develop 3D printing technology. We will figure out how to build self-replicating robot probes, that our artificial intelligence will get better, our robotics will get better, our space-based manufacturing and assembly will get better, and eventually we'll get to a point where we can have a factory build a copy of a factory out there in space. And once you're all, in microgravity zipping around the solar system. You just find an asteroid and then set up shop, and then you pump out copies of yourself. And then you send those spacecraft out to other star systems, and then they arrive at other star systems and they make more copies of themselves, and then they all go to other star systems. And these are von Neumann probes. Let's say there were 10 civilizations that are operating in the Milky Way at various times. And it would take about 10 million years, less, a million years, to send one self-replicating robot probe that would then go to 2 star systems. Then they would go to 2 star systems. And you get to this place where you've now investigated the entire Milky Way. Well, we don't see the big giant alien factory in the asteroid belt right now pumping out spacecraft, but we haven't looked very hard. We have analyzed the surface of the moon down to, let's say, 0.5 meter across. We've analyzed the surface of Mars down to 0.5 meter across, but we've barely begun to explore the asteroid belt, as well as any of the moons in the outer solar system. And there could very well be some ancient alien factory that is mining out asteroids and turning them into von Neumann probes and sending them off to various corners of the Milky Way. And so for me, that sort of, why I feel like we're alone in the universe is that we don't see the von Neumann probes. We don't see them crawling around the solar system, making copies of themselves. That the solar system appears to be just raw wilderness, just rocks and ice as far as the eye can see, and no alien factories. But I love this, right? That we go out into the asteroid belt and we're thinking about how we're going to start mining these asteroids, and we come across an asteroid that has clearly been dismantled by some kind of machine. Like, the cuts are clean. When you look at a quarry where people are mining stone, it's very different from a naturally forming feature. Like, something happened, some intelligence made this happen. And it would be so weird for us to go out into the asteroid belt and find one of these asteroids and go, look at this evidence. Someone was here and someone built stuff here. And it could very well be out there. We just haven't looked yet. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question is all about how we measure the mass of black holes. And I will put a link in the show notes. All right, those are all the questions that we had this week. Thank you everyone who asked your questions in the YouTube comments. Everybody who joined me for the live show, which we record Monday at 5 p.m. sometime in the world. There'll be a link here on the channel that'll tell you where our next event is going to be and when. Let's see, if you're watching this, then it'll be 5 p.m. Monday Pacific Standard Time. But you're going to want to double check. Now, I'm going to rant about subscriptions and algorithms in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bear Lake Roofing, Brian Bodie, Carradwin, Chuck Hawkins, Commander Balak, Cy Nelson, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jerry Mattern, Jim Berg, Jordan Young, Marcel Smith, Michael Purcell, Modsel, Paul Robach, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler-Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So last week, I explained why we do the longer versions over on Patreon and why we tell you to go over and watch them, even though they're completely free and there's no ads in them. And a bunch of people said in the comments that you don't let the algorithm choose what you watch here on YouTube. You use your subscriptions tab. And that was really interesting to me because it's very rare. But it is exactly the right way to use YouTube. You need to be in control of the videos that you watch. You need to decide that there are certain channels that produce content that you enjoy, and then you go to the subscriptions tab and you just check and see what all of the creators are that have made things that you like. And that, if you're no longer enjoying the video from some creator, unsubscribe, unfollow them. But that's not what the most people do. So I went and looked at my analytics, and YouTube told me that on average, for the people who go and link off of some part of YouTube to watch our videos, comparatively, 10% are using that subscriptions link, and 90% are viewing it through the algorithm, either on the homepage or because they see one of the videos over on the right-hand side. And so, and I'm like this too, I'll open up YouTube and I'll be like, what to watch? Oh, here's some video that is currently outraging people and I'll watch this. And then I realized that there was some video from a creator that I really liked that I've been missing because the algorithm had decided it would rather show me, more Andor commentary than videos from channels that I really do enjoy. So that's my, try that out. If you're feeling like the claws of the algorithm are getting into your brain and controlling your day, and that you are just refreshing and watching more videos and refreshing, because it'll just do this to you all day. Try only interacting with YouTube through your subscriptions button, which is in the upper left, and just watch the videos there, and then don't go to your homepage. And you can be more extreme about this. I mean, I know there are Chrome plugins you can put in that will stop the rest of YouTube from showing up, only what you have on your subscriptions tab. I think you do need to drop into the bigger stream and see what new stuff is out there and what's in the zeitgeist. So that's important too. But yeah, try to spend more time from the subscriptions tab than just letting the algorithm choose for you or whatever. Do what you want. I'm not your dad. All right, we'll see you next time.